Let's do section 11.3, page 565, exercise 43, which reads, find the area of the region described. And for exercise 43, we're looking at the region inside the convex limicon described by r equals 4 plus 2 cosine theta. And I think it's important, just as when we did this with rectangular coordinates, to graph the region. So this is kind of like a squashed circle. And we should remember that the way that we find the area between the origin and a curve in polar coordinates is by performing the integral from alpha to beta of 1/2 times f of theta squared d theta. And we need to remember that f of theta is equal to r. And in order to get the curve that I have over here, I graphed it from 0 is less than or equal to theta is less than or equal to 2 pi. And graphing for that gave me once around the curve. So when I find my area here, I'm going to do the integral from 0 to 2 pi. Like I said, that took me all the way around my curve. I'm going to have 1/2. And then I'm going to have f of theta, or r, which is defined up here. So that's going to be 4 plus 2 cosine theta squared d theta. And you could just plug this into your calculator, but I suspect that if I multiply out those parentheses that are squared, I'm going to be able to integrate this term by term. So I'm going to move out that 1/2. And I'm going to have the integral from 0 to 2 pi, and then I'm going to square what's in the parentheses. So that's going to give me 16 plus 16 cosine theta plus 4 cosine squared theta, and that's all times d theta. And then I'm going to distribute this 1/2 because I noticed that every term in here is divisible by 2. So this is going to become the integral from 0 to 2 pi of 8 plus 8 cosine theta plus 2 cosine squared theta d theta. Now I can integrate this whole thing term by term. The only term that will give me trouble is this cosine squared theta, but I can look that up in Appendix A7 in the back of your textbook, and you should probably get used to looking for integrals there when you don't immediately know what they are. So if I integrate term by term, I'm going to get 8 theta plus 8 times the antiderivative of cosine theta, which is sine theta, plus 2 times the antiderivative of cosine squared theta, which is going to be theta over 2 plus the sine of 2 theta over 4. And again, you need to look that up in the appendix in the back of your book. And we're going to evaluate all of this from 0 to 2 pi. So I think we're ready to substitute in our upper limit. So that's going to give me 8 times 2 pi plus 8 times the sine of 2 pi, which will be 0, plus 2 times 2 pi over 2, plus the sine of 4 pi, which is again going to be 0, minus this whole thing with 0 substituted in. And I think if you look closely, you'll see that that's just going to give us a 0. I can cancel those 2's, and so I'm going to end up with 16 pi plus 2 pi, or an area of 18 pi.